Hi, everybody. A couple of videos back, I told you that a function written in the form y equals mx plus b is said to be in slope-intercept form. But I didn't tell you why this is called slope-intercept form. I left that as a bit of a mystery, and now I'm going to answer half of the mystery for you, the part about where it says here intercept. The reason that it says intercept over here is because b, this number over here, tells us what the y-intercept is. So it's very simple. Whatever the b is, that tells us exactly where the y-intercept is going to be if we were to graph the solutions on a coordinate plane like this. Okay, so this line represents all of the solutions to this equation over here, and the arrows at the end mean that the line just keeps going, okay, because there are actually an infinite number of solutions. And just to show you that the points on this line are actually solutions to this equation, let me just pick one of the points. So let's just say this point over here, which has an x value of 3 and a y value of -3. If I just plug that in here, so y is -3 and x is 3, so I get 2/3 times 3 minus 5. So this is like times 3 over 1. And these 3's would just cancel, and I get 2 over 1, which is just 2. So I have 2 minus 5 on the right side, -3 on the left side, and 2 minus 5 is -3. Okay, so I have -3 on the right and -3 on the left. Okay, so yeah, so this actually is a solution to this equation here. And in fact, I could have done that with any point along the line. All of these points are solutions to this equation. So that's a little bit of a review, but now let's get into the fact that the b tells us what the y-intercept is. So what is the y-intercept for this graph? You remember from the last video, it's actually very simple. You just look at the y-axis. So this is the y-axis over here. And then you ask yourself, where does this function cross the y-axis? And it crosses it right over here. And that is the point 0, right? So at that point, the x value is 0, and the y value is -5. So that is the point 0, -5. And you could also see that that's a solution by plugging 0 in for x here and -5 for y, but I'm not going to do that right now. I just want to point out that, look over here. We have a -5 over here and a -5 over here. That looks very suspicious, right? It's actually not a coincidence. If I rewrite this in exactly the form y equals mx plus b, so I can change that -5 to plus -5, and I can write y equals 2/3 x plus -5. Then I can see that my b value is -5, and that tells me exactly what the y-intercept is. It tells me that the y value for the y-intercept is going to be -5. But Mr. Friedman, that's the y value. What about this told me that the x value was 0? Well, you don't have to look at this because the y-intercept always has an x value of 0. So you don't even have to think about that one. You can just put the 0 in there. And then this b value tells you what the y coordinate part of the y-intercept would be. Okay? All right. Now, the fact that this b value, which was in this example -5, tells us exactly where the y-intercept is, that's not just a lucky coincidence. There's a reason why that happens. Let me rewrite this equation again. Y equals 2/3 x minus 5. Now, if I asked you to find the y-intercept for this equation, but I did not give you this graph over here. So let me just, do I have shapes on here? No, I think I have shapes in here though. Let me cover this whole thing. Let's say I was really mean and I gave you this equation, and I told you to tell me what the y-intercept for this equation was, but I did not let, whoops, but I did not let you see this graph over here. And I also didn't tell you about this. I didn't tell you the fact that you could just look at the b value and that tells you what the y-intercept is. So you didn't know that. Just pretend you didn't know that. Pretend that it's 5 minutes ago before you started watching this video and you didn't know this little trick here that b tells you where the y-intercept is, and you also didn't have this convenient graph that I gave you. How could you look at that equation and figure out what the y-intercept was? Well, you can pause the video and try thinking about it for a minute. Well, here's how you could do it. You could remember that for any y-intercept, not just the y-intercept for this equation, but the y-intercept for any equation always occurs where x is equal to 0, because anywhere along the y-axis, x is always 0. So you could say to yourself, if I want to figure out where the y-intercept would be, I would have to figure out what y value would make this equation true when x is 0. So you could plug 0 in here for x and solve for y. That would give you y equals 2/3 times 0 minus 5. And 2/3 times 0 is just 0, right? So that gives you 0 minus 5 is equal to y, or y equals 0 minus 5 is -5. So that tells you that when x is 0, y is -5. Well, that must be the y-intercept, because the y-intercept has to be the point where x is 0. All right? And that would work for any equation which is in this form. So it doesn't have to be, the m doesn't have to be 2/3 and the b doesn't have to be -5. We could just take the general case and say that, we'll say m is m and b is b. Okay, so what happens if I plug 0 in for x here? No matter what my value for m is, so my m value could be 2/3, or it could be 4/7, or it could be -12, or it could be 100.6. It doesn't matter what it is. Anytime I multiply my m with 0, which is what I'm plugging in for x to find the y-intercept, I would get 0, right? Anything times 0 is 0. So no matter what my m is, this would turn out to be 0, and the rest of my equation would just look like y equals 0 plus b. But 0 plus b, anything plus 0 is just itself, right? So this is just b. So that tells me that if I see an equation which is in this form, then b must be where the y-intercept is, because that's what I get when I plug 0 in for x. That's the value that I get for y after plugging 0 in for x. So it's not just a coincidence that this number happens to be where the y-intercept is. There's a reason for that. So let's just look at another example now. Let me get rid of this. Well, it doesn't matter. I'm moving down anyway. Okay, so over here is another equation. And just to show you that this graph is actually, it does actually show you the solutions to this equation, I'll just pick one example here. So what about the point 1, 2? Just to show you that it does actually work. So if I plug in 1 for x and 2 for y, and I get 2 over -2 equals 1 minus 2. Just copy that. So 2 divided by -2 is -1, and 1 minus 2 is also -1. So yes, it works. And in fact, I could have picked any point along this graph and plugged the x in here and the y in here, and then both sides would have been the same. So these are all of the solutions to this equation. And remember, there are an infinite number of solutions. Now, what is the y-intercept for this graph? Well, just look at the graph. Here's the y-axis. And where does this function cross the y-axis. It crosses it right over here, and that is the point 0, 4. Okay? Now, you might be wondering to yourself, wait a minute, Mr. Friedman, you told me that this b value over here always tells me where the y-intercept is. But I can see clearly from this graph that the y-intercept is 0, 4, but you don't have a 4 over here. You have a -2. So shouldn't the y-intercept be 0, -2 over here? No. And the reason is that this is not in this form yet. I have this -2 over here, which the y is being divided by right now. So to really get this equation into this form, I have to fiddle around with it a little bit. So I want to get rid of that -2 so the y is all by itself. If I do that, if I multiply this side by -2 and do the same thing on the other side, multiply this by -2, that cancels. I get y equals -2 times x would give me -2x. And this -2, which I can think of as -2 because it's like plus -2, times -2 would give me a +4. So I could put a +4 here. So you can see that it works. I wasn't lying. When I do fiddle around with the equation that I'm given, and if I can get it into this into this slope-intercept form, then the b value, which is the value that does not have x next to it, the value that's, okay, so there's no x in this term here, that term tells me where I would find the y-intercept on the graph. But remember, I would also have to put a 0 in front of it. So the y-intercept is not just 4, it's 0, 4. Okay? All right. Have a great day.